Welcome back to Module 1, Section 2. In this section, we're going to be talking about absolute value equations and how to solve them. So before we really get into solving absolute value equations, we want to define what absolute value means mathematically. An absolute value, essentially, is the distance a number is from 0. So we're just going to define it as the distance from 0. A lot of times people think about this on a number line. So for example, we have the absolute value of 2. If you weren't sure how this was notated, right here, the 2 bars on the outside of the 2 represent absolute value. So if I draw a little number line over here, and in that number line I put 0 in the middle, there's 1, there's 2. What is the distance from 2 to 0? Well, that is 2 units. So the absolute value of 2 is 2. The next example is the absolute value of negative 2. So let me continue my number line into the negatives. Here's negative 2. Well, what is that distance from 0? That is also 2 units away from 0. So what you notice is that when you take the absolute value of something, you're going to get a positive number. So let's use this concept to look at solving absolute value equations. Solving this first absolute value equation. Solving this first absolute value equation. We have the absolute value of x equals 7. Well, we need a number that works for x that gives us 7. Well, if you noticed up above, if we looked at the previous example right here, there were 2 numbers that gave us the absolute value and spit out 2. So there must be 2 numbers that gives us 7. The numbers and how we're going to set this up would be 7 and negative 7. Because if I plugged in negative 7, the absolute value of that is 7. If I plugged in positive 7, the absolute value is 7. So essentially when we set up these equations, we're going to set the inside of the absolute value equal to positive 7 and the inside of the absolute value equal to negative 7. Let's use that strategy on the one on the right. So in this equation, we have the absolute value isolated by itself right here, 8x plus 4 equals 28. So let's set up 2 equations. One over here and one over here. Just like before, we're going to say 8x plus 4 equals positive 28. Then we're going to say 8x plus 4 equals negative 28. And you notice when I set up these 2 equations, the absolute value sign goes away because we're just rewriting it as 2 equations we know how to solve. From here, let's just finish it by subtracting 4, dividing by 8, and one solution to this problem is x equals 3. Let's finish the other one. Also divide by 8 and negative 4. Now you might be wondering, these 2 aren't opposite values like 7 and negative 7. How is it possible that they work? Well, to do that, we can just check this out down below. I'm going to check my answer and say, well, if I plug in 3 for x, does it give me 28? Well, 8 times 3, 24. 24 plus 4 is 28. That one works. I'm going to go ahead and erase that. 3. And now I'm going to put in negative 4. So now I'm going to check if negative 4 works in our original equation. Does that give me a true statement? Well, 8 times negative 4 is negative 32. Negative 32 plus that additional 4 is negative 28. And of course, the absolute value of a negative 28 is positive 28. So we know both of these are the correct solutions. This next one's a little more complex. And what we notice on this one that's different from the previous ones is that this absolute value is no longer isolated on one side. So that's the first thing we're always going to want to do. And I'm going to make a note. We're going to isolate the absolute value first. So what I see up here is that we have a 10 added to it and a negative 6 multiplied. So I'm going to subtract the 10 from both sides first. So then I'm left with negative 6. Absolute value of 2n plus 2 equals negative 96. Then since this is multiplied by the absolute value, I'm going to divide from negative 6 because they cancel. Absolute value of 2n plus 2 gives me, well, negative 96 divided by negative 6 is 16. From here, this part looks just like the last question we did, just different numbers. So I'm going to split up my two equations and say here's one, well, 2n plus 2 equals 16. Here's the other, 2n plus 2 equals negative 16. And just solve both of these individually. So subtract 2 from both sides and divide both sides by 2. You get 7. Subtract 2 from both sides. Divide both sides by 2 and negative 9. Let's look at this last one. Again, we don't have the absolute value isolated. So another note, let's isolate the absolute value. To isolate this, I need to divide that 2. I get the absolute value of x plus 1 equals negative 3. Whoops, negative 3. There we go. Now that it's by itself, set up into the two equations. Here's one. X plus 1 equals negative 3. And then I'm going to switch this sign and say x plus 1 equals positive 3. Go ahead and solve by subtracting 1. You get negative 4. And then you get 2. And I'm going to go ahead and check these two values into the original statement up here, the original equation. So let me pull down a bit so you can still see that equation. And let's plug in. So I'm checking my work. 2, and then the absolute value of negative 4 plus 1. Does that give me negative 6? Negative 4 plus 1 is negative 3. The absolute value of negative 3 is positive 3. So is 2 times 3 equal to negative 6? It's not. So that first solution is no good. We'll strike that out. Let's test 2. I'm going to go in here and just erase that and put in a 2 into the original equation because that's the other solution. 2 plus 1, 3. The absolute value of 3 is 3. So is 2 times 3 equal to negative 6? We just had that question. It's not. This one's no good. So that means there is, I'll write it off to the side, no solution to this guy. Now it seems pretty tedious to have to go back and check every time because occasionally we'll get no solution. So my final question is, when does an absolute value equation have no solution? That might be easier for us to recognize, so we don't have to check every single one. Well, if you notice with that last one, we had, and I'm going to go ahead and bring you back up there, an absolute value equal a negative number. So when I get the absolute value by itself, I'm going to highlight it right now. When I get the absolute value by itself, right here, just what I highlighted. The absolute value is isolated. We notice that it's equal to a negative number, -3. Back to our definition, the absolute value is always going to be a positive number. So what we can say is, without even having to solve these types of equations, when the absolute value, and I'm going to abbreviate that, is isolated, and equals, let's rephrase that and say, and equals a negative. So when I get the absolute value isolated by itself, and it equals a negative. Another example, the absolute value of 2x plus 5 equals -10. This would have no solution.